Hi everybody, thanks for watching another math video. This one will be about transforming quadratic and absolute value functions. Quadratic functions I'm going to assume that you're fairly familiar with. Absolute value functions might be a new one for you. Alright, so we'll take a look at both of those and you'll see how similar in many ways they really are. Alright, so let's just re-familiarize ourselves with something that I'm going to guess you're pretty familiar with already, the vertex form of a quadratic function. Y equals a times x minus h squared plus k. You've seen this before if you've been in my classes, and if you have not been in my classes and have never seen this before, well, this will hopefully introduce you to a very, very useful form, useful way of writing the equation for a quadratic function. In this function right here, the value of a controls the steepness and the direction of the graph. We're going to talk about a first for a little while. We'll catch up to h and k in a second, and you'll probably figure out some things about h and k, even with these examples here. But first, let's talk about what does a do? What does it mean to control the steepness and the direction of the graph? Well, for examples here, I'm going to look at the equation y equals a times x minus 3 squared minus 1. So they'll all have that same equation, same location, but the value of a will be different. So here's a basic one where a equals 1. I hope that's clear enough for you to see that the coordinates of the vertex down there are positive 3, negative 1. All right, so look at the equation, x minus 3 squared minus 1, and the coordinates of the vertex are positive 3, negative 1. And once again, a equals 1 there, so that's just kind of what you might say a normal positive parabola. Here's a parabola where a equals 3. Now it is 3 times steeper. All right, so a is controlling the steepness of the parabola. When you think of the word steep, especially maybe in the context of a line, steepness and slope are kind of synonymous with each other. And slope is the ratio of vertical change divided by horizontal change. Now that's true for a parabola too, and just think in terms of steepness. All right, so we are increasing the vertical change of the parabola over the same horizontal change. So it gets steeper. All right, that's what a equaling 3 does. If a was a small number, like between 0 and 1, like 0.25, what it does is it decreases the steepness of the graph, makes the parabola seem like it's opening up wider. In fact, all parabolas are geometrically similar, and the value of a is really just a scale factor on that parabola. Scale factors in this case for parabolas, however, can be negative. And if a parabola has a negative value there in front of the parentheses, all it does is turn the parabola upside down. Now that comment there that showed up on the bottom of the screen is very important to me, I think, because one of the things that you notice doesn't change is the coordinates of the vertex. The value of a does not change the coordinates of the vertex. Every one of those 4 parabolas has the same coordinates for the vertex. So positive, negative, big number, small number, it does not change where the vertex is. It just changes the steepness and the direction of the graph. All right? So that's what a does. Let's take a look now at what h and k do to the graph. And as you may know, the point hk is the vertex of the graph. So the vertex form gives you the coordinates of the vertex. That's really kind of its main gift to us, if we kind of want to call it that, is the coordinates of the vertex right there in the equation once you kind of learn how to interpret it. Here's a graph of x minus 6 squared minus 3, and the coordinates of the vertex are positive 6, negative 3. So notice that kind of switch that happens there. You see x minus 6 in the equation, but it's positive 6 for the x coordinate. Here's another one. Now it's x plus 2 squared minus 5. So x plus 2, and if you look at the coordinates there, the x coordinate is negative 2. Here's a couple more. All right? There's one that's upside down. Here's another one that's upside down. And in both of those cases, you see that when you see x minus 3 or x plus 5, you see x equals positive 3 or x equals negative 5 for the parabola. So it's almost like the inside the parentheses there is kind of the opposite. In fact, that's what a lot of people think, is that h is the opposite. All right? X minus h moves the parabola to the right, and x plus h moves the parabola to the left. I would like to say, however, that it's not really opposite, because if the x coordinate of a parabola is a positive number, the equation is going to say x minus that number. All right? Whereas if the x coordinate of a parabola is a negative number, you would write that as x minus that negative number, but nobody writes x minus negative 2 or x minus negative 5. They just write x plus 2 or x plus 5. So it's okay to think of it as h being sort of the opposite of what's showing up in the equation, but it's really not. Okay, it's based on the way the equation structure is formulated. Okay, so that's a vertex form of a parabola. All right, and here is the vertex form for an absolute value graph. Notice the similarities between these two equations. They both have an a, they both have an h, they both have a k, and what's really nice is that all three of those little parameters do exactly the same thing on an absolute value graph as they do for a parabola. All right, so let's call this thing the vertex form of an absolute value function. That's what it is. Okay, and in the same way, a controls the steepness and the direction of the graph, and the point hk is the vertex of the graph. Now, you might not be that familiar with what an absolute value function looks like. And not only is the equation similar to the equation for a parabola, but the graph, in a way, is similar also. It's a V-shaped graph, or maybe an upside-down V-shaped graph. And that vertex right there, that's the point of the V. So you could, if you really wanted to kind of, bend the rules here, think of an absolute value graph in the same way that you think of a parabola, only now it's got straight sides. All right? So let's have a look at this graph a little bit more there. You see that the absolute value of x minus 3 plus 2, and the coordinates of the vertex are positive 3, positive 2. Okay? So you see that. You also may have noticed that a equals 1 in this equation. All right? Now, so yes, it is true that a equals 1. But look at the slope of the right-hand side. All right? It goes up 4 and over 4. The slope of that side is also equal to 1. All right? That's not a coincidence. The value of a, in fact, is the actual slope of the right-hand side of the graph. So in a way, absolute value graphs are a little bit easier to conceptualize into graph because a is an actual slope number. It's not just a scale factor that increases the sides, the steepness of a curving line. It's a straight line, and if you can calculate slope, then you can plot it on a graph. All right, let's look at a couple more real quick here. Here's 2 times the absolute value of x plus 1 minus 2, and there's the coordinates of the vertex at negative 1, negative 2, and the slope of that right-hand side there is 2. That's because a equals 2. All right, here's another one. Y equals negative 1/2 times the absolute value of x plus 1 plus 5. Same kinds of thing there. There's the vertex at negative 1, positive 5. And a is negative 1/2, and the slope of the right-hand side is negative 1/2, down 1 and over 2. All right, here's the third one. Let me pause a little bit here and see if you can figure this out. Note on the graph what the coordinates of the vertex are, and then look at the right-hand side of that graph and see if you can figure out what the slope of that side is. I'll give you a second or two to kind of look at that. You can pause the video, of course, if you want. So, well, you think that's enough time? Okay, let's have a look at the equation here. It's 5 over 4 times the absolute value of x minus 1 minus 5. There's your vertex at 1, negative 5. The slope of that right-hand side of the graph is up 5 over 4, and there's the equation. All right? So for absolute value functions, a actually equals the slope of the right-hand side of the graph. All right? So that's a really nice feature of absolute value graphs. Let's summarize here with a couple of things that we can say about these two function types. All right, the vertex form of these graphs, all right, absolute value functions and quadratic functions, they use a, h, and k to control the graph's location and shape, and it happens in the same way for both of these function types, for quadratic and absolute value functions. As a matter of fact, however, A, H, and K do the same thing for lots of different kinds of functions. For cubic graphs, for exponential graphs, for reciprocal graphs, for logarithmic graphs, for all kinds of different kinds of graphs, A, H, and K do very similar, if not exactly the same things. So learning about them here in this video here is really going to help you understand a great variety of function types. All right? But that's a different video. So I'm really glad you tuned in to watch. Hope you learned a couple of things. So please be well, be safe, be smart, and try to do some good math. Okay? Thanks. Bye-bye.